Hello guys, welcome to Apex Tutorials. In this video we are going to focus on differentiation using the product rule. We use the product rule when we have a product of two functions that we have to differentiate. So suppose we have a function y is equals to f of x multiplied by g of x. The derivative of y will be equals to the derivative of f of x multiplied by the original function g of x plus the derivative of the function g of x multiplied by the original function f of x. So in this case, for the first question, we have y is equals to tan 2x multiplied by e to the power 3x. So if we are going to differentiate this, so the derivative of y will be equals to the derivative of the tan 2x multiplied by the original function e to the power 3x plus the derivative of e to the power 3x multiplied by the original function tan 2x. So in this case, we have to differentiate the tan 2x. So the derivative of tan 2x is equals to sec squared 2x, and according to the chain rule, we also have to differentiate the inner function 2x. So the derivative of the 2x is equals to 2. And we have to multiply this by the original function e to the power 3x plus the derivative of the e to the power 3x. So the derivative of e to the power 3x is e to the power 3x multiplied by the derivative of the 3x according to the chain rule. So the derivative of the 3x is equals to 3, and we have to multiply this by the original function tan of 2x. So the derivative of y simplified will be equals to 2 multiplied by e to the power 3x multiplied by sec squared 2x plus 3 multiplied by e to the power 3x multiplied by the tan of 2x. For the second question, we have to differentiate y is equals to the square root of x squared minus x multiplied by sine x. So we have two functions, the square root of x squared minus x and the sine x. So in order for us to differentiate this properly, let's rewrite this as x squared minus x raised to the power 1 over 2 instead of expressing it in the form of that square root multiplied by the sine x. So the derivative of this will be equals to the derivative of the x squared minus x raised to the power 1 over 2 multiplied by the sine x, and later on we differentiate the sine x and we multiply it by this original function squared minus x raised to the power 1 over 2. So let's differentiate the x squared minus x raised to the power 1 over 2. So we multiply by the exponent and we write the inner function as it is 1 over 2, and then we subtract the 1, and from here we differentiate the inner function x squared minus x. The derivative of the x squared is equals to 2x, and the derivative of the x is equals to 1, and we multiply this by the sine x plus the derivative of the sine x, which is equals to cos x, and we multiply this by x squared minus x raised to the power 1 over 2. So from here it's just simplification. So this will be equals to 1 over 2 into x squared minus x. 1 over 2 minus 1 will be equals to negative 1 over 2 multiplied by the 2x minus 1 and the sine x plus the cos of x squared minus x raised to the power 1 over 2. This will be equals to 1 over 2 multiplied by 1 over, so we are taking this x squared minus x raised to the power negative 1 over 2 from the numerator to the denominator, the exponent is going to change sign from negative 1 over 2 to positive 1 over 2. This is multiplied by 2x minus 1 multiplied by the sin x plus, sorry about that, cos x multiplied by, so we can now express this as the square root of x squared minus x. And also let's express, so 1 multiplied by 1 multiplied by 2x minus 1 will be equals to 2x minus 1 multiplied by the sin x. So at the denominator we have 2 multiplied by the square root of x squared minus x plus cos x multiplied by the square root of x squared minus x, and this will be our answer for the second question. So for the third question, we have y is equals to ln of x cubed multiplied by cos squared x. So once again, let's introduce the formula for the product rule. So if we have y is equals to f of x multiplied by g of x, the derivative of y will be equals to the derivative of f of x multiplied by the original function g of x plus the derivative of g of x multiplied by the original function f of x. So we have to now determine the derivative of y. So the derivative of ln x cubed will be equals to 1 over whatever it is that is inside the ln. So what's inside the ln is the x cubed multiplied by the derivative of whatever it is that is inside the ln. So the derivative of the x cubed will be equals to 3x squared. We multiply this by the original function cos squared x plus the derivative of the cos squared x. So in order for us to successfully differentiate the cos squared x, let's write it as cos x squared. So now we differentiate cos x squared, so it will be much easier for us to differentiate cos x raised to the power 2. So the derivative of this will be equals to 2 multiplied by cos x into 2 raised to the power 2 minus 1. So now we have to differentiate what's inside the parenthesis. So the derivative of the cos x is equals to negative sin x. Remember, when you differentiate any trigonometric function which starts with the letter c, you always get a minus. So this is multiplied by the original function ln of x cubed. So the derivative of y will be equals to 3. So the x squared divided by the x cubed will be 1 over x cos squared x plus 2 times cos x. The 2 minus 1 will be equals to 1 multiplied by the negative. So this negative multiplied by this negative multiplied by this positive will be equals to our negative sin x multiplied by the ln of x cubed. So we can simplify this further. So we have 3 cos squared x divided by x minus the 2 cos x sin x. We can rewrite it as sine of 2x multiplied by ln of x cubed, or you can just leave it as minus 2 cos x sin x. Moving on to the last question, we have y is equals to 2x minus 4 raised to the power 2 multiplied by ln of x. So according to the product rule, we have to differentiate first the 2x minus 4 raised to the power 2, and we multiply it with this ln x. Later on, we differentiate this ln x and we multiply it with 2x minus 4 raised to the power 2. So the derivative will be equals to the derivative of the 2x minus 4 raised to the power 2. So we have the 2 from the exponent, multiplying this whole thing. We have 2x minus 4, which we are not going to differentiate as of yet. 2 minus 1, so after we minus the 1, that's when we go and differentiate the inner function 2x minus 4. So the derivative of the 2x minus 4 will be equals to the derivative of the 2x, which is 2. The derivative of this negative 4 will be equals to 0. We multiply this by the original function ln x plus the derivative now of the ln x, which is equals to 1 over whatever it is that is inside the ln, which is x, multiplied by the derivative of what's inside the ln. So the derivative of the x is equals to 1, so 1 multiplied by 1 will just be 1, and we multiply this by the original function 2x minus 4 raised to the power 2. So now we simplify. We have the derivative of y is equals to, so this 2 multiplied by that 2 will be equals to 4 into 2x minus 4. The 2 minus 1 will be equals to 1 multiplied by the ln x plus 1 over x multiplied by 2x minus 4, and this will be our answer for the final question. So if you have any questions, you can leave them in the comment section below. If you find these videos useful, consider subscribing, liking and sharing this video with your fellow mates.